Hello everyone, I'm Belenzamo and I will take you to voltage regulation. Voltage regulation is defined as the change in terminal voltage from no load to full load expressed as a percentage of rated voltage, which is given by E minus V divided by V times 100, where E is the no load induced EMF and V is the terminal voltage. So for the voltage regulation determination, we have two methods, basically the direct loading and the indirect loading. For the direct loading, we have it is usually for the small alternators, and it is the formula for the voltage regulation is given same as the above percentage regulation, where it's given by EA minus V divided by V times 100, where EA is the no load voltage. So for the indirect loading method, it's usually for the large alternators. Here we have three methods: EMF, MMF and zero power factor method. So to determine only the EMF method, we need to have open circuit characteristics and short circuit characteristics. And in this method, the flux produced by the rotor and starter are replaced by the equivalent EMF, so they are called as EMF method. So for the open circuit characteristics, we run the alternator without load, and the field current is raised in suitable steps until the voltage between any pair of the terminal of the armature winding is above the rated EMF. And this is the data we got after doing our practical, following the connection as given for the open circuit. Here we find the terminal voltage with respect to the field current. And as for the short circuit characteristics, it is done where the alternator is connected to load, and it is all similar to the open circuit, but the only difference is that here without the instead of the terminal voltage, we find the short circuit current with respect to the field current given. And this is the data that we got from the practical, and after following the circuit connection as per given, where we have, instead of voltage here, we have the ammeter, so which means that we got the short circuit current. And this is the curve which will give you the open circuit characteristics and short circuit characteristics with the terminal voltage and short circuit current in the y-axis with respect to field current. And as for the second one, we have the MMF method, which is also known as ampere turn method. And in this method, the magnetic circuit is considered to be unsaturated, and both the reactance drop are replaced by their equivalent MMF, and it also requires the short circuit and open circuit characteristics, which is similar to the EMF method. And in this method, it will usually give values less than the actual one, and this is the data we got after following the circuit connection as per given here for the open circuit MMF method. And as for the short circuit, it's also similar to the above one, where we have the data after following the connection as per the diagram given. And this graph will give you the MMF method characteristics from the open and short, similar to the EMF method.
Zero power factor, which is also known as Potter-Tanger method. Purely inductive load must be connected to the alternator for plotting the zero power factor characteristics. The shape of the zero power factor characteristic is very much to that of open circuit characteristics. It makes use of both the EMF and MMF method, where it gives the most accurate result compared to the other two. This method is based on the separation of the armature leakage, reactance drop, and the armature reaction effect. This is the curve for the zero power factor, and from the open circuit characteristic curve and the full load zero power factor curve, we will get this triangle which is known as the Potter-Tanger method. And this is the circuit diagram for the zero power factor. Thank you.